Polygons in the coordinate plane. We can use coordinates as vertices and connect the dots to draw polygons on a coordinate plane. Think of the coordinates as the corners of a polygon, and we're connecting those corners with straight lines to form shapes. So here's our first example where we have 2 points plotted on the coordinate plane. We have point A and point B. Point A is located at 2, 1, and point B is located at 2, 4. So now the challenge is we want to list 4 possible coordinates for point C that would form a right triangle. So first we have to think, what is a right triangle? A right triangle is a triangle that has a right or 90-degree angle. So we need to place point C somewhere that makes that happen when we connect these points. That would be the vertices of the right triangle. So think about, should C go to the left of A or B? Should it go to the right? Should it go above B, below A? Should it go in the middle? Maybe a combination of both. There's a lot of different ordered pairs. There's a lot of different coordinates that C could be, but there's only a certain amount that will create that right triangle. So let's test it out. First, let's place C maybe here to the left of A and B in a random spot. So if we try to form that triangle and I connect the vertices, we do get a triangle, but that's an acute triangle. That's not creating the right angle. So we need to think of a strategy that's maybe going to straighten out the angle. So what we can do is we can move C. Well, it looks like this is almost a right angle here, but if we wanted a right angle, we would have to, you can even kind of draw in the right angle that you would want. We would want to see a right angle here. So we need to move C lower, and then maybe that will give us our answer. So let's try to move it down a little bit. Let's try to move C here. So now if we try to connect the coordinates, connect the points, and make them the vertices, now that we've lowered C, we do have that right angle with point A. It looks like the lines that are connecting C and A and B are now creating that right angle, and there's a right triangle. So we have C located here at -1, 1. So now the question becomes, that's one possible coordinate. We need 3 others or more to see what will happen. Well, we moved C down, so let's continue to move C down further on the y-axis. Right now it was up at 2 and that wasn't good enough. So what about 1? So now let's try to put it at a y value of 0. So now let's see if we can put it below, or even not just 0, let's do -1. So now if we create our triangle, well, now as we can see, now we have an obtuse triangle. We do not have that right angle anymore. So it seems like the y-coordinate of point C has to be at 1 in order to have that right triangle, forming the right angle with CA and AB, those 2 sides. We can't have it above or below. It had to be at 1. And that's forming the right angle down here, but we could have also had the possibility of forming the right angle up with the coordinate of B. So let's take a look at what that would entail. Now you can use the same kind of logic where we had point A and it was a y value of 1, that point being on that y value of 1, creating that right angle. Well, think the B value has a y value of 4. So let's assume if we were to create a right angle here, if we were to create that 90-degree angle box, we would want the point C to be somewhere on the y-coordinate of 4. Maybe let's move the y-coordinate here, -3, 4. And if we tried to create the triangle, now it's coming off of coordinate B with the y value of 4, and then now let's connect it with point A, and we have that right triangle again. So it seems like the y value of 4 and the y value of 1 is what's going to create that right angle and make that right triangle. In fact, any point on the coordinate plane that has a y-coordinate of 1 or 4 will create a right triangle because you have those y values of 1 and 4 in the points A and B, and they have the same x-coordinate of 2, so then changing the x-coordinate doesn't matter, it's all about that y-coordinate. So let's look at some examples. It said to list 4, so you can have the example of first 0, 1. So 0, 1, if we connect the vertices, creates a right triangle. We have 4, 4. So 4, 4. Oh, 4, 4 is creating that right triangle. We can have 5, 1 is creating that right triangle. And negative 6, 4 is creating that right triangle. So again, the main idea though is that the y value had to be the same as point A with a 1, like these 2 points, or a y value of 4, which is the same as point B, which is the same as these 2 points. So a lot of times the coordinates themselves can reveal how to create the polygon and the shape in the coordinate plane. So now let's try a different example. So first it says to plot and label the following points. So we have H is 4, 3. So that means from the origin, we're going to have our point here at 1, 2, 3, 4 units to the right and 1, 2, 3 units up. There's our point 4, 3. Then we're going to, and then let's label that H because that's now H. Then we have our point 0, 3, so we're going to have 0 units to the left or right of the origin and going up 3 units. So that'll be point I. And then we have point J, which is 4, 0, so that's 4 units to the right and 0 units up or down. So we can label that point J. So now we have 3 points on the coordinate plane that we can try to create a polygon with. In fact, let's be the challenge. What fourth point, so another point, would form a rectangle named HIJK? So we have the vertices of HI and J, so we're looking for that fourth point that would be K. We want to see where can we place that on the coordinate plane to meet the qualifications of a rectangle. So think what makes a rectangle. You have your 90-degree angles for all 4 angles, and the rectangle has to be the opposite sides have to be congruent or the same length. So we have to meet those qualifications. We can't just randomly place our fourth point in any random spot. We have to think about what will create that shape. So let's connect the 3 vertices we already have. If we connect I to H, let me actually connect it a little straighter because we are supposed to be having straight vertices or straight lines connecting the vertices, and then we have I to H and H to J. So we already have our right angle here, so we would want to be creating a right angle with this vertice J and another line segment. We would want to be creating a right angle with this vertice I and another line segment. And so therefore, we also have to make sure that the line segment is the same length as the opposite side. So if this line segment, we can count from I to H is 1, 2, 3, 4 units from the y-axis, and J is 4 units from the y-axis, we would want that other point to be 4 units away from J. So if I connect here, it looks like I should be putting that point right on the origin. And then I would be 3 units away from the origin, and J is 3 units away from H. So it looks like the origin is the place to put the fourth point that would form a rectangle. Right? So we have I, H, K, and J. So we have our points here. So now K would be 0, 0, and it would complete and form a rectangle. Again, we would have our sides that are opposite and congruent, and it would be creating 4 right angles. So you can play around with different coordinates to create different polygons on the coordinate plane, and just making sure you're meeting the qualifications of your shapes and seeing if there's only one possibility. So here there was only the one possibility for the 4th point, but with the right triangle there were lots of different possibilities. So it all depends on the problem and the placement of your coordinates as your vertices.